Alright, so here's our pendulum here. We're going to have three different height settings in which we're going to collect data from the pendulum swing. The first one is at about this height, and then we're going to alter the height by just taking the string here and wrapping it around this piece of wood there, and then it brings it up to our second height. If we wrap it around one more time, it's going to be at our third height. And for each time, we're going to have the sensor roughly in a position like that, in order to collect the data from the swinging pendulum.
So this is the hardware setup for our Arduino and our ultrasonic sensor. So Arduino is connected to the laptop through the cable. And then we have this breadboard here with the ultrasonic sensor, our RGB LED, and the resistors to power the RGB or to add resistance so they don't fry. So we have the VCC and ground coming directly from the Arduino to the breadboard, and that also connects to the VCC and ground ports on the ultrasonic sensor. And then the trig and echo ports on the ultrasonic sensor are connected to the digital pins 6 and 7 on the Arduino. And at the same time, 9 and 8 are the digital pins connected to the RGB LED. And the RGB LED is also connected to the ground. So those pins can be used within MATLAB to control and collect data from the VCC, from the ultrasonic sensor.
Here we have currently our project running some recording of data. You see that there is a sine wave being represented by the pendulum swinging back and forth. At the top here we have the actual sensor data, so distance versus time, and the filter data down below using a median filter. In the settings tab here, you can actually set how long the data will run for, and also set the median window size. So if I set it to a window of 3, you'll see that the filter data actually smooths out. You can also change the COM port and any of the pins that the hardware is connected to. We also have a reset in here, which will reset the whole thing. You could also save the file. So if we want to save the file, we can just go to Downloads, select Folder, and it'll actually save it as the file name as an Excel file. We can also load our data. So I actually have a test of using a short string. So if we actually see the data is actually having a higher frequency, and it's a little bit more unstable since it's not able to capture as much data points. We can also change the median window size here, say to 7, and it'll do an extreme case where it basically just annihilates everything. Here's a quick walkthrough of our code. Here's all the variables that we actually declare. We have the X and Y data, data filtered, and some others. Here's our graph data function, which helps graph the data as you saw in the previous video. We have all these that run during the startup of our app. And here is our while loop that actually reads the data in a loop until the time length that the user sets is greater than TOC. And if we keep going, we also have the initialize button. Everywhere we are using try catches to make sure that no errors go through and bug the user. We also, here's the rest of our functions and whatnot that correlate to our drop-down menus.
So how does our model compare to the theory of pendulums model? So this is one of our tests that I've loaded up. And as you can see, the period is about 1 second long. And the string length for this model is about 24.5 centimeters. And using the period of oscillation equation here from the model of pendulums, you can see that the period equals 2 pi the length divided by the gravitational constant. And so we can find our own gravitational constant and kind of estimate the gravity on Earth using this. So we had our 1 second time times 2 pi, and this is using MathCAD to solve this. And then our 24.5 centimeters, and then we divided by the gravity. So we solve for gravity, and it gives us 9.6, which is pretty close to what we know as the true gravitational constant of 9.8 meters per second. It's great.